Steve Fleming is one of the world's leading neuroscientists. His life's work is the study of metacognition, a remarkable ability to think about thinking. This mental process has a huge influence over our self-awareness and ability to make good judgments. He's also fascinated in how metacognition and artificial intelligence may one day come together.
Hey folks, welcome to the Evolving Leader Podcast. I'm Scott Allender.
And I'm John Gomes.
How are you feeling today, John?
Alert.
You look alert.
That's for my guest, actually. I need to make sure that, I'm really
You do
paying
look more
attention.
alert than you normally do. Yes, I will say it's working.
Yeah, I did some training this morning on alertness. How are you feeling?
I'm feeling good. It's been a long week, bit tired, but really feeling a lot of joy, being at the precipice of a restful weekend ahead. So excited about that, and particularly excited to be here with you today because you and I have been supremely focused in this show about exploring new ideas around how the brain constructs our sense of self and reality. And we've been fortunate, really fortunate, to have gone on this journey with some amazing minds, including Lisa Feldman Barrett on how emotions are constructed, and Bo Lotto, of course, on the emerging understanding of perception. And we've had Mark Soms and Anil Seth on trying to understand what is consciousness itself. And today we are joined by yet another brilliant neuroscientist who is undoubtedly going to push us even further into new territories and new understandings. So would you like to do the honors today of introducing him to our listeners?
Yes, I would. Thank you. Well, today we're joined by one of the world's leading neuroscientists, Professor Steve Fleming, who is Professor of Cognitive Neuroscience and Sir Henry Dale Wellcome Trust Royal Society Fellow at the Department of Experimental Psychology. He leads the metacognition group at the Wellcome Center for Human Neuroimaging. Professor Fleming, welcome to the Evolving Leader.
Thanks so much. Thanks so much for having me. Really excited to be here.
How are you feeling?
I'm good. I'm also one of my students passed his PhD Viva this morning, so we're all in celebratory mood here.
That's a really good moment, I'm sure.
Yes.
Could you start by giving us a definition of metacognition, what it is and what are its main functions?
Sure. So metacognition literally means cognition about cognition, or thinking about thinking. So it's this reflective capacity that we have to think about how our minds are working. And perhaps the best way to introduce it is with a couple of concrete examples. So an example of metacognition about memory or learning would be, for instance, if you're planning to go to the shops and you start to accumulate a list in your head, and then you think to yourself, hang on a minute, I'm not going to be able to remember this. I better write it down. So that's a judgment about your own memory capacity. You're thinking to yourself, okay, it's not going to be good enough to hold all this list in mind. So I then outsource it to the external world. I write it down on paper or on my phone or whatever. So immediately we see that functional connection where having good metacognition is then good for leveraging external resources to help us get things done. Another example in a completely different domain might be when we think to ourselves, our vision or other aspects of our cognitive function are failing, and that might prompt us to go and seek help. So if you think your vision is failing, that might prompt you to go and get a new pair of glasses or something, or get it checked in some way. And so that's a judgment, again, not about the external world. We don't think the external world is suddenly become blurry. We think to ourselves, hang on, my perceptual system's not functioning the way it should be. And so that's, again, a judgment about how our own minds and brains are working. And we think this notion of explicit self-awareness, this being able to build a model of how we ourselves are functioning, is something that is uniquely human, at least in its most rarefied forms. And we think it supercharges many different aspects of our lives, and I'm sure we'll get into some of these.
So there are different forms of this. We have implicit and explicit, or conscious and unconscious metacognition. What's the difference? I mean, it may seem obvious, but what do they provide us in terms of cognitive functionality?
Yeah, so implicit metacognition refers to this suite of neural autopilots that are constantly adjusting our actions, the way that we go about moving through the world. So an example of implicit metacognition would be, for instance, when you step on a moving escalator, the self-monitoring systems in your body are automatically adjusting your posture. They predict the fact that you're going to need that small adjustment of posture to keep you upright as you go on the moving escalator. And that kind of self-monitoring, that adjustment can become exposed when the escalator is broken and stationary, because then you step on it and you slightly stumble forward. And that's because it's all unconscious. All that kind of self-monitoring is going on usually under the hood. And there's what we think is happening there, the neuroscience of implicit monitoring, is very interested in this notion of prediction, these automatic predictions that the brain is constantly making, both about what's coming up in the external world, but also about our own actions, our own, when we reach out to pick up a glass, then the system is predicting the fact the glass will end up in our hands. And if it doesn't, if it gets knocked off course, then we can automatically correct for that. And there's been a lot of beautiful experimental neuroscience that's been done to show that brain regions such as the cerebellum are involved in this rapid automatic error correction. And so in the book, I use the analogy of an autopilot in an aircraft, where the pilots might actually be unaware of the fact that to keep the plane flying level, it's performing thousands of tiny corrections every few seconds. And so that's what I mean by implicit metacognition, is kind of autopilot working away under the hood. And in contrast, explicit metacognition is when some aspects of that self-monitoring become conscious. And that's the kind of things I was talking about before, when we can think to ourselves, okay, my memory is not working as it used to, or I need to invest more time in learning a topic because I realized that I don't have as much knowledge as I thought I did on it. Those were more explicit, conscious judgments of how our minds are working.
So you start your excellent book that John mentioned in the introduction, Know Thyself, with an exploration of how our brains are constantly solving inverse problems, a sort of reverse reasoning, trying to understand root causes of things. Now, Professor Anil Seth was on our show recently and touched on abductive reasoning, and we as humans kind of fundamentally struggling with abductive reasoning. Can you help us understand these concepts from your approach and your research?
Yeah, so I mean, Anil is a good friend, and we share a lot of interest in how the brain solves these inverse problems. So maybe it's useful to say a bit about those. So when we think of how the brain perceives the outside world, this is what computer scientists and vision scientists call an ill-posed problem. So you have all this information streaming into the senses, but actually when it gets converted into neural signals, you get quite an impoverished stream of information. So the retina, for instance, for vision is only a 2D sheet of cells, and from that 2D impoverished input, we somehow reconstruct the richness of the three-dimensional visual world. And some decades of beautiful theoretical modeling have been done going back to people like Helmholtz in the 19th century to suggest that the way the brain is solving this problem is effectively inverting a causal model of what caused those signals. So it builds a prediction of if I had this pattern of data hitting my retina, then that would be consistent with seeing a cup, for instance. Whereas if I had a slightly different pattern, that would be consistent with seeing a plate. And even though you can't be certain which one it is, by getting enough data, you resolve the ambiguity in the incoming information. And so in a sense, and to use Anil's phrase, perception is then a construction. It's not something we passively receive. We construct what we perceive in the outside world. We bring to the table various priors and assumptions about how the world looks. And to solve those inverse problems, it turns out that being exquisitely sensitive to uncertainty is really useful, because the intuition is that if I have very uncertain and noisy data coming in, for instance, if I'm perceiving a scene in very low light, or maybe it's in fog, or there's not very high quality input, then I should rely much more on my assumptions. I should rely much more on my priors. And that's perhaps why when we're walking home in the dark, we're more likely to think we see things in the shadows. Whereas if things are brightly lit, then we don't misperceive things and we don't make up stories about what we might be seeing. And that can all be explained by this very delicate balance between the uncertainty of the input and whether to what extent we bring to bear our priors and assumptions when we're solving those inverse problems. And so the argument I make in the book is the fact that the brain of presumably many animals, not just humans, need to solve these kind of inverse problems. It makes sense then that we get these uncertainty signals in a sense for free. They come along with the machinery of inference that's required to solve perceptual inverse problems. And that's, I think, the lowest, most implicit level of metacognition. This sense of uncertainty about perceptual inputs is one of the most primitive forms, I think, of metacognition.
So that example that you gave of why we see things in the dark is really helpful, because I think, for a lot of the listeners, trying to connect the dots up between what's going on inside the brain and the subjective experience that we have, I think that's kind of where a lot of your work has really made some huge progress. You suggest that metacognition results from pooling this broad array of inputs from many different sources within the brain. And therefore, it has a kind of abstract quality to it that transcends perception and action. If you were trying to describe metacognition in experiential terms, can you tell us what you think it feels like? So that and I think you've given an example actually, which is really helpful. But is there any other ways in which we might sense metacognition?
Yeah, so I think that if we build up from there, in the sense that we have this perceptual machinery in place to build models of the outside world, and because we're computing uncertainty in order to solve those inverse problems, that means we can also harness that uncertainty to doubt what we perceive. So we get this kind of extra check, if you like, on whether things are really as they seem. And on the action side, we then have all that kind of self-monitoring machinery that I talked about in the example of stumbling on the escalator that is going on under the hood as well, to try and, in a sense, provide a similar check and balance on our actions and to make sure they stay on track. And there's actually an influential school of thought that comes from my colleague here at UCL, Carl Friston, who has developed a theory known as active inference. And the idea now is that there is no real difference between perception and action. So the old view of perception and action in neuroscience used to be that the brain kind of takes in information and processes it in some way, that's perception, and then it does something to it and then spits out commands to make us walk and talk and so on. And so that's the old view. And the newer Bayesian view, the idea now is that what action is another way of trying to minimize these prediction errors. So the perceptual system is trying to minimize errors in its model of the world. But then if there are still errors, then you can act to bring things into line with what you hope the model of the world to be. So if my model of the world is I should be drinking coffee, then the idea is my arm just reaches out and gets the coffee mug because that matches the world to my model of the world. So that's a kind of rough approximation of what active inference is. And so what that means is, the implication of that is that there's a very deep connection between how uncertainty is being computed on the perceptual side, but also how uncertainty is being computed on the action side. Because again, the same kind of ideas are in play. If we have a very precise prior about what we expect to happen on the action side, that will mean that our actions are more likely to fulfill that prior. So again, there's a kind of uncertainty plays a role throughout the system. And what I was trying to put forward in the book is this idea that this explicit conscious level of metacognition is, in a sense, riding on top of both that perception action dynamic. And we are then sensitive to this more global, abstract sense of confidence in things going well. So not only are we sensitive to, say, uncertainty in perceiving this particular quantity, we have this more general sense of, okay, I'm confident in being able to get this task done. Or I am confident in my memory working as it should. And so those are the more kind of abstract, explicit levels of self-awareness that I think, and there's growing evidence for this, and we can talk about maybe some of the experiments on this, but there's growing evidence for, in a sense, this explicit level of self-awareness integrating lots of different domain-specific signatures of uncertainty in the system.
So that's really interesting, because I think sometimes these things are kind of positioned as an either or, and you're talking about the fact that they are just different aspects of awareness that are interplaying with one another. And we could get into free will and all sorts of topics, but the thing that I'm interested in here is about how that serves well-being, for example, because if your unconscious awareness is making a whole bunch of kind of receiving a whole bunch of error signals, either in terms of just your alertness, your nutrition, or whatever, and your explicit awareness is trying to do something that's really demanding. You have a kind of a clash there of those two things, and that for me feels very much a kind of experience of being compromised. I'd be interested to think about what kind of experiments are you looking at that help to kind of see when the two systems are at odds.
Yeah, so there is this, I think, interesting interplay between unconscious self-monitoring and the kind of explicit awareness that is, in a sense, riding on top of that. And there are, I think, situations where, and one well-studied aspect of this is skilled performance, where you don't really want the explicit awareness aspect to be in play anymore. And so there were these lovely studies of college golfers by Sean Belock and colleagues, where they showed that when expert golfers were asked to explicitly reflect on how they were taking the golf shot, that they became worse at hitting the golf ball. Whereas if they were then asked to attend to something meaningless, like the number of beeps on a tape, they became better. And this wasn't the case for novices, where it was important for the novices to be able to actively think about how they're doing something, just like we would when we're learning to drive, for instance. We would want to be able to think about how we're doing everything, but once it becomes fully practiced, then that's a case where, in a sense, it's even better for our minds to be wandering away and doing something else, because then we can just get the job done. And I think the reason that kind of thing happens is it's it in a sense showcases how explicit self-awareness is not just epiphenomenal. It's not just something that sits there watching the system working, if you like. It's part of the system. It has a functional impact. And if your model is well tuned and it's working well, so if you're hitting the golf ball perfectly or you're driving your car very well, then there's no need to improve it or optimize it or change it in any way. And so that's when you, in a sense, want to minimize these higher level interventions from metacognition. You want to minimize that aspect getting in the way, if you like. And I think that's what's happening in those experiments, that it's being artificially activated, and then it just can't help but try and change things, and it does so in a detrimental way because it's already, they don't need to be changing anything.
So I'm passionate about this idea of self-awareness from a leadership perspective, particularly because, at least from an emotional intelligence point of view, it's something that can be developed and improved over time. Can you talk to us a little bit more about how metacognition can be thought of as an attribute that can be developed?
Yes, sure. So metacognition is something that we think is malleable. It's not set in stone. And one way we can investigate this is by, first of all, measuring people's metacognitive acuity in the lab. And the way we do this is by asking them to carry out simple tasks where they rate how confident they are at performing that task. And then we analyze the match between confidence and performance. And so the intuition is that if you have high confidence when you're right and lower confidence when you're wrong, that's a sign of having good metacognition. And what we found, and others have found this as well, that when you ask people to practice those kind of tasks and now give people feedback, not only on their performance, but also on how accurate their confidence is. So in a sense, try and improve their calibration of their confidence estimates. Then this ends up over time, and we've done these experiments over multiple days, over a period of a couple of weeks. Over time, people become better and better at realizing when they've made errors and noticing when they've got the answer right. And what's super interesting about one of the experiments we ran on this is that that training effect then transfers to a completely untrained task. So it seems that we're, in a sense, able to boost this more abstract level of metacognition. It's not that we're just boosting your metacognition on this one single task. It seems like we're having an effect more broadly in improving your self-awareness about multiple things you could be doing. Now, we're just scratched the surface on this. We've got a lot more research to do to see what benefits that, if any, might have for people's daily lives and how it might impact on well-being and so on. These are all things we're interested in. But I think what we're excited by is it's almost like a proof of concept that this well-defined capacity to think about and reflect on our performance can be trained.
That's really interesting.
Yeah, I mean, in your book, you give some really good examples of how you do that, and it feels like when people are able to almost hack their own assumptions or their predictions that they're making about their certainty around things. That kind of leads me on to the next thing, which is you've done quite a lot of interesting work around people who hold very dogmatic views, which is a hot topic at the moment. And you said that you found that people with low metacognition was one of the best predictors of people holding those kind of views. People unwilling to reassess, their thoughts and beliefs in light of new information. Can you talk to us a little bit about some of the experiments work that you did there and what you learned?
Sure. So the work on linking metacognition with real world beliefs was led by a former PhD student of mine, Max Rollwager. And what we were interested in there was really this question. It relates to this abstract nature of metacognition, as to whether the kind of things we were measuring in the lab mattered for our self-awareness of everyday beliefs and in a sense, the capacity to reflect on what we know and don't know in the real world. And we were hopeful that obviously was the case, because we were hoping our laboratory experiments were tapping into something more general, but we didn't know that at the time. And so one way we set out to test this was to collect data from hundreds of people over the web. So they logged into a website, they performed a little metacognition test that we developed. So they got asked to perform lots and lots of judgments about which of two boxes contain more dots, and then rate their confidence in those judgments. So these are very low level judgments. They shouldn't really have any vested interest in being more aware or less aware of their decisions on that kind of task. But what we could then measure is, again, how well did their confidence track their performance in that low level task. And then we also asked them to fill out a series of questionnaires that assayed their political beliefs, but also, more importantly, how dogmatic those beliefs are. And they answered questions such as, how much do I believe that I'm right and everyone else is wrong? And how much is it important to listen to others' opinions and update my beliefs accordingly? That kind of series of questions. And from the answers to those questions, we could extract out this number that we gave to each person, which was, well, two numbers. One was, where are they on the political spectrum? And the second one was how dogmatic were they? And as you might imagine, those two numbers were linked, because people who were more extreme, either on the left or the right, tended to be more dogmatic, but they weren't perfectly correlated. So in theory, you could be a moderate dogmatist. You could be like, I really think I should be moderate and I'm not going to listen to anybody else about that. And so we did see, this independent aspect of personality, or the way that you viewed the world, that we called dogmatism, or political dogmatism. And what we found was that when we then looked at the relationship between that and our task, the one thing that repeatedly came out of those experiments was that it wasn't about your performance on the task itself that mattered for your political beliefs. It wasn't that you were just better or worse at the dots task. What really mattered was how well you could track your performance with your confidence judgments. So this metacognitive sensitivity. And what we found was that people who were more metacognitively sensitive about that task also were less likely to be dogmatic in their political beliefs. So in a sense, what that's telling us is that it looks like we're tapping into some general abstract capacity for self-awareness that not only provides a benefit in being able to recognize when you're wrong on some dumb task that we're giving you, but also provides a benefit for recognizing when you might be wrong about really important things in everyday life.
Do you, this might sit outside your what you're researching, but do you see a trend upward in dogmatism? Do you see more of that in your research? And if so, do you have a theory on why?
It's really interesting. We did, and so we actually, and this was initially it was a bit frustrating for us, because what happened was we published one paper in 2018, and the data for that was collected a year and a half prior, so shortly after Trump being elected. This was all collected from a US sample, and I should point out, I think I did say that before, but this is not a commentary on political ideology at all, because in fact we saw people were almost equally dogmatic at the far right and also the far left. So you had dogmatic Democrats and dogmatic Republicans. But we published that one study in 2018, and then we did another study which we ended up publishing last year, a couple of years later, and we gave another big sample of American participants the same questionnaire battery, and we couldn't replicate the previous factor solution. So what we tend to do when we analyze these data is we throw all the questionnaires into a big PCA or factor analysis, and the same solution wasn't coming out. We were like, that's kind of annoying, because that's not the question we want to ask here. We just want to kind of do that and then get on with answering the questions about metacognition. And what we eventually discovered was that the reason it wasn't replicating, or one of the reasons we think it might not replicate, is that, as you say, there was just more of this dogmatic factor in the data second time around. And I saw on Twitter just this morning that there was a big study of Reddit sentiment published in Nature today, which was suggesting something similar, that it wasn't as if individuals were becoming more dogmatic, but when you took a random sample from the pool, the people who were joining the online community were swelling the ranks of the dogmatic, and that seems to be what we saw in our data as well.
Mm-hmm. So, moving from self-awareness for a moment, tell us about your thoughts on how metacognition can help us to understand other people more.
So we think that there is a close link between self-awareness and the awareness we have of other people's minds. And this is often in psychology referred to as theory of mind. So the capacity to understand and be aware of what other people's mental states might be. And so this is not something that we can easily see in their behavior, but it's something that we infer about them. It's another kind of inverse problem, right? So we want to go from the data coming in to some inference about the causes of their behavior. So one example might be, if you walk past someone in the street who you know and they don't acknowledge you, then either you could say, oh, they must not have seen me, or you could make a more negative inference and say, well, actually they were trying to ignore me and they hate me and so on. So this kind of inference we make on mental states is a very interesting problem for cognitive neuroscience to understand, like, how does that work? How do we do that? But also an important problem for mental health, because as that example shows, if you're making maladaptive inferences, then you can rapidly get caught in a cycle of thinking everyone hates you and thinking everyone is thinking ill of you. Yeah. And that is what you often see in cases of depression, for instance. So we've been interested in this ability to think about other minds, to think about other people's mental states from a cognitive neuroscience or computational neuroscience perspective. And we've been very interested in the idea that it might share machinery in the head for thinking about ourselves. And this is an old idea in philosophy that in some sense, self-awareness, the way we become aware of ourselves, is maybe turning the same machinery for theory of mind on ourselves. And it kind of fell out of favor in philosophy because there was this notion of self-awareness was somehow special. We had this kind of direct access to our own minds. It can't be an inference because it just feels so immediate. But I think recently the work on metacognition and situating that work in the broader Bayesian brain framework suggests that metacognition is an inference like any other. It's a problem. It's a problem the brain is trying to solve. How we build a model of ourselves, and that's potentially a similar problem to building a model of how other people operate. And so we've done some recent work suggesting that that might be the case empirically as well. So we find that people's metacognitive ability is correlated with their ability to think about and solve theory of mind problems. And there's been some beautiful recent work from David Williams's lab in the UK suggesting that, showing that people with autism not only have deficits in theory of mind, which have been known for many years, but also seem to have problems with thinking about themselves with metacognition. And we've also recently done a meta-analysis of brain imaging studies looking at the kind of networks that are activated when you engage in metacognition about yourself, but also when you engage in theory of mind about other people. And they're not the same, but you do see quite a bit of overlap in the prefrontal cortex, in the medial prefrontal cortex. So we're very interested in those brain areas because they suggest that there might be some kind of common machinery involved in both metacognition and thinking about other people.
The scope of what you're doing is really huge. I mean, you seem to be in all sorts of different applications of this, which is very exciting. And I also read in about your work in thinking about artificial intelligence and how this, this understanding of knowing when we don't know helps, us to maybe think about how we could get AI to doubt itself. And you gave a really interesting example. I love this, which is kind of like a self-driving car glowing in different colors depending on its confidence on the road. I thought that's hilarious. You kind of sort of, I can imagine, your car starts turning red, meaning that it doesn't really know where it's going, or it's not really sure whether it's safe. Grab the wheel.
Exactly.
Tell us a little bit how you're thinking about metacognitions, the breakthroughs you're making, and how that might inform artificial intelligence.
Yeah, so we do just as your the example that you referred to there of the self-driving car. We think that one thing, and this is not something that I'm bringing to the table, machine learning and AI researchers have known this for many years, that the systems, the neural network systems that they are building often struggle with out of distribution data. So when they see things that they haven't been trained on before, they're often overconfident about the guesses they make in those situations, whereas a human would go, hang on, I just don't know really what I'm doing here, so I probably should slow down if I'm driving, for instance, and figure it out. And so what I was suggesting in that FT piece was perhaps you could imagine a future where if we can somehow build the capacity for implicit tracking of confidence and uncertainty in AI systems as a a routine aspect of building those systems, and then have those signals be broadcast to the world, then would that have benefits not only for the AI itself, so it could effectively recognize when it's in a situation where it didn't know what it was doing, but also benefits for trust of human AI teams. So as you were saying, if I think, hang on, my kind of robot collaborator here doesn't really know what they're doing, so I should take over. That I think would provide a much smoother interaction in human machine teams. And this is something we're actively working on. So I'm collaborating with roboticists at the Oxford Robotics Institute on a new UKRI program grant, which is seeking to, the broader goal of the grant is to build more autonomous robots. And one component of that is to think about ways of building metacognition into the robots. And there's been some, really interesting developments on how you can track uncertainty and confidence in neural nets, for instance. But so far, at least, there hasn't been this notion of metacognition about what the system's doing as a whole. So you might have the ability to track confidence about what the camera is seeing, for instance. But this idea of a kind of more global confidence signal that humans seem to do effortlessly, that hasn't really been brought into the robotics world. And that's something we're actively working on.
When we start to embrace more embedded technology in human beings, so we've obviously got robotic arms and things like that, but we're going to have computer interfaces. And we know that the brain's neuroplasticity allows us to be able to adapt and extend into that. How are you thinking about that? How does metacognition work in parallel when it's directly integrated into our bodies?
So that potentially could be another route to, in a sense, providing self-monitoring of our machine extensions to the human mind. So, one, I think, exciting vision of AI is that rather than it, in a sense, competing with humans, that it collaborates with us, and that we rely on it just as pilots rely on the autopilot in their aircraft to take away the kind of more mundane, routine things they need to be doing from moment to moment. And that's how a lot of technology over the years has kind of seeped into our lives. So we don't refer to the autopilot in a 747 as an AI anymore, but effectively that's what it is, right? So it's a system that is optimized to take control from humans. And so I think that when that kind of technology becomes inherent to daily life, it's, in a sense, taking on some of the things that we used to do and don't do anymore. The problem with that is that we then perhaps lose what I call metacognitive contact with that kind of automation. So if it were to start going wrong or start failing, we wouldn't necessarily know about it. And that has been recognized as the cause of some unfortunate air crashes or air disasters, where the autopilot, in a sense, had lost control of the plane, but the pilots didn't really realize it until too late. And I think that this is obviously a long way in the future for now, but we do know increasingly that it's possible for the brain to interface with, say, perceptual or motor prosthetics. And it's not a huge leap of imagination to suggest that we could, in a sense, plug in brain-computer interfaces higher up the system. So now you would have a entirely automated device that's sitting outside of you and getting on with its thing. But because in some sense we're monitoring it just the same way that I might monitor the way I hit a tennis ball, for instance, then if that were to go awry, then we would become naturally more aware of it. So in a sense, the pilots could be sitting there doing nothing, but they would have this sense, this metacognitive sense of whether the autopilot was doing what it should be doing or not. And I think that is how, as humans, we routinely engage in metacognition about our own bodies. So we don't understand on a rational level how the eye works or the biomechanics of the arm, and yet we can recognize when we might need a new pair of glasses or when our tennis swing goes awry. And I think that's quite an interesting vision of how we might meld with AI in the future, that we don't necessarily need to intervene constantly, but we just have that awareness of when things might be going wrong.
What is most exciting for you right now? What are the kind of the standout things that you're working on?
So right now we're interested in actually branching out from work on metacognition to start tackling the, in some ways, thornier problem of conscious awareness. So in a sense, I've referred to conscious awareness in our discussion, but almost like as a given. Some aspects of metacognition are unconscious. That's all that suite of self-monitoring algorithms that we have, and other aspects of metacognition are conscious. But that kind of begs the question: well, why are some things conscious and others not? And this is obviously a big question. It's an age-old question. It's one that I've always been interested in, but never really figured out a good way of tackling. And I've always been a broader part of this consciousness science community, where there's been many fascinating and innovative theories that have been developed of like what makes some information processing in the brain conscious and others not conscious. And one thing we're gearing up to do at the moment in the lab is to try and think of ways of expanding out this predictive processing machinery that I talked about for perception, and to start thinking in a more formal way, like what would you need to add to those kind of models to get something that looks like awareness. And what I mean by awareness here is not the ineffable subjective experience aspect, not whether the lights are on or not, just the functional aspect of being able to say in some conceptual form, I am aware of this processing that's going on in my perceptual model. And even solving that problem, it sounds kind of simple. It's like, well, why don't you just build on a module that says I'm aware, I'm not aware? But it turns out to be actually much more difficult than that, because that system, the way that humans seem to be able to do it, we seem to be able to be aware of loads of different things. It's very highly combinatorial. I can say I'm aware of the stuff on my desk, but I can also say I'm aware of feeling a bit hungry. And this notion, this concept of awareness, we seem to be able to apply it to ourselves in lots and lots of different ways. And that implies that it's actually something that's quite abstract, and that it might take a while to develop when we're kids. And so this just notion of being able to comment on and report on our awareness of our mental states, of what's happening in our minds and bodies, is something that computationally is underspecified, but it's something that we think we can now start to specify, and that allows us to start to test hypotheses about how it might work in the brain. And even though that's not the same as saying we are studying consciousness itself, I think it provides a really interesting starting point for starting to reverse engineer how a system might be able to generate reports of awareness.
Hi everyone, I'm Phil Kirby, producer of The Evolving Leader. It seems almost unbelievable to be saying this, but here we are now in season 4 of the podcast. Just incredible. Time has absolutely flown. So we can continue to evolve, we would really love it if you could give us just 3 or 4 minutes of your time to complete our listener survey using the link in the show notes. While you're feeling generous, please also go to Apple Podcast and leave us a 5-star rating and a review.
Can I just take a quick detour for a second? Because we have a number of people who ask us about what it's like to be a neuroscientist, and and particularly young people who are thinking about it as a career. And of course, it's a huge subject, ranging from different dimensions of science from physics through chemistry and neurochemistry right up to the psychology kind of end of the spectrum. Can you tell us what it's like to work in your lab and what's going on? Can you paint a picture of what people are actually doing? And pre-COVID, obviously.
Right. Yeah. I mean, I think first of all, I should say that even though we often do use the term neuroscientists in a very broad way, really we are psychologists first and foremost. And that was originally my background. I did a degree in experimental psychology, and then I went on to do a PhD in cognitive neuroscience. And the field of cognitive neuroscience is, I would say, 80% cognitive. Like, we spend most of our time sitting around thinking about how we should design an experiment to test this part of perception or this part of memory or that, this aspect of how the mind works. And then once we've really pinned it down, and that takes up most of our time, then we'll go and spend a couple of weeks using the big brain imaging facilities here to also then study how that mental process is linked to increasingly detailed assays of brain function. And so, in a sense, as cognitive neuroscientists, I feel like we're somewhat imposter neuroscientists, because we're not day to day looking at neurons or looking at how, looking at brain function every single day. But I guess that is the ultimate goal, is that ultimately we do want to understand how the human brain supports all these complex cognitive abilities that we have. And so just to come to your question about what a day in the life looks like, I think the students in my group spend a lot of time, they spend a lot of time designing experiments, running simulations of theoretical models. And so practically that usually means being fluent in one or more programming languages. We often use MATLAB and Python and R. And we have quite a strong grounding in computational modeling, particularly Bayesian graphical modeling in our group. So when we come up with an idea we want to test, we often first try and simulate what that might look like in silico. And so we have models that we've built up over the years of how a confidence estimate is produced, literally the number that you would give on that trial, like how confident am I in that particular decision? Or we have a model of like, how aware should I be of a stimulus on this particular trial? And then we can simulate that for thousands and thousands of judgments in the computer and start to build up a picture of what patterns we might expect in the data. And once we have those simulations running, we then also usually collect data. Increasingly, we're collecting these data over the web. Even pre-COVID, we were starting to do that just because it was easier and quicker. And so we will ask people to do simple experiments where they will be pressing buttons in response to particular stimuli and making these confidence judgments or awareness judgments on every decision. And then those provide us with the raw data that we then compare against our theoretical models. And all that, to get to that point, usually requires days and days of programming, both of programming the simulations, programming the task, collecting the data. And then once you've done all that, then usually we then are in a position to do some brain imaging as well, to ask how does that process that we've now pinned down with our theoretical model relate to patterns of brain activity. But surprisingly, for, say, a student who comes into the lab to do a PhD in neuroscience in our group, they might only spend 2 or 3 weeks of their year actually collecting brain imaging data. All the rest is leading up to it and then analyzing the data afterwards. So there's a lot of sitting at a desk with a high-powered computer.
Steve, you've covered a lot of ground today. And as we near the end of our time, I'm wondering for our leaders that are listening, is there some elements of this that you would distill down as important takeaways for them to consider?
Particularly in how they could build their own metacognition.
Yes, I think one thing that's useful to know first off is that we think of metacognition both theoretically but also empirically in the data as being in some sense separate to raw intelligence, raw ability in a particular area. So you can be, very smart and kind of getting on with things, but if you lack the metacognition to realize when things might be going off track, then that can sometimes be quite dangerous. And we all probably know people who are very smart but lacking completely in self-awareness. And we see that in the data as well, that when we give people simple IQ tests in the lab, that's usually completely uncorrelated with their metacognitive prowess. And so I think one thing that I've kind of taken away from that is that, and I'm sure this is part of your interest as well, is that in a sense self-awareness is an extra skill. It's not just enough to be great at your job. You need to also have that capacity to, in some sense, take a third person perspective on yourself and recognize, are things going well, are things going badly? And one way that we can do this is by paying close attention to situations in which metacognition might fail. And I have a whole chapter in the book dedicated to this, on avoiding failures of metacognition, because I think even though the training stuff is exciting, really the best way of boosting your metacognition is just to adeptly avoid the situations in which it might be most likely to fail. And those, unfortunately, are also situations where in high octane environments, in business environments, in company environments, you might be under a lot of stress. And those are the situations when metacognition and self-awareness often fail. And again, there's a good reason for that, because we know that stress causes particular detriments to the function of the prefrontal cortex, and that's a key hub for metacognition. And we know from work done in the lab that when you put people in stressful settings, their metacognition is one of the first things to go. And so I think just in a sense, gaining what I like to call metacognition, so this, in a sense, extra knowledge about how self-awareness works and why it might fail, hopefully can protect us from those situations. They can make us realize that, hang on, if I'm going to be really needing to engage in some deep reflective thinking here, I don't want to be doing that at a time of stress. And equally, I think it helps us be slightly more compassionate in our relationships with other people, because the paradox of losing self-awareness is that you don't usually know that you've lost it. And I found that in my own life that's helped to some degree, because after the fact, my wife might say to me, you realize you weren't especially great to live with this past week because you've been really stressed. And I was like, I was perfectly fine. Nothing changed. But then now I kind of realized, well, if my metacognition was also impaired during that week, then I probably wouldn't have been in a great position to know about it. So I think it's, in a sense, recognizing the situations where it might fail, but also perhaps placing a bit more trust in other people's view of ourselves, because often where we need to rely on those outside views of how we're doing are the situations when we need it most.
Well, I have to say, this has been an amazing conversation, and I'd really recommend our listeners get a copy of your book. It covers a lot of ground, and it's very interesting, but it's beautifully written as well. It's very obviously you. It's not an academic textbook or anything like that. It's obviously your life story brought to bringing out all of the insights that you've gained over years. So I thoroughly recommend it.
Steve, thank you. Honestly, I could listen to you for hours on this topic. I feel like you've covered tons of ground, but yet I feel like we've barely scratched the surface at the same time, and it's so helpful to me and to our listeners, and we really thank you for your time.
Well, thank you both. It's been great fun. I've really enjoyed our conversation.
Thank you for joining us, and until next time, remember, the world is evolving. Are you?